4.5 billion years. That's how long our planet has spun through the cosmos, a tiny speck in an endless universe. We humans have called it home for just a sliver of that time, building cities, dreaming of the stars and believing we're the first to claim this world. But what if we're wrong? What if Earth has seen other civilizations, intelligent beings who rose, thrived, and vanished long before us? In this documentary, we dive into the shadows of Earth's deep past, searching for clues to lost societies, and confronting a chilling question: did they fall to the same forces that threaten us today? The Great Filter, a mysterious barrier that might stop any civilization from reaching the stars, could be part of our planet's story. Join us as we explore what these forgotten worlds mean for humanity's future, and whether we can defy the odds to become more than just another chapter in Earth's ancient history. The universe is huge. It's so big that it's hard to even imagine. There are about 100 billion stars in our Milky Way galaxy alone, and some scientists think there could be 2 trillion galaxies out there. That's a lot of stars, a lot of planets, and a lot of places where life could exist. With all those possibilities, you'd think we'd see signs of life somewhere else, maybe a radio signal, a flashing light, or some kind of spaceship zipping by. But we don't. The universe seems quiet, too quiet. This is what people call the Fermi paradox, named after a scientist named Enrico Fermi, who back in 1950 asked a simple question during lunch with his friends: where is everybody? That question has puzzled people ever since. If the universe is so full of stars and planets, why haven't we found any aliens? Why does it feel like we're alone? The Fermi paradox isn't just about aliens though. It's about something deeper. It makes us wonder about life, about intelligence, and about what it means to exist in a universe this big. If life is easy to start, if the stuff that makes life possible, like water and carbon, is all over the place, then why don't we see it? Scientists have been thinking about this for decades. They've come up with all kinds of ideas. Maybe life is really rare. Maybe intelligent life is even rarer. Or maybe intelligent life shows up, but something stops it from lasting long enough to say hello. That something is what people call the Great Filter. It's like a wall that stops civilizations from growing too big or lasting too long. The Great Filter could be anything: a disaster, a mistake, or just bad luck that wipes out life before it can spread across the stars. Now, let's take this idea and turn it toward Earth. What if we're not the first ones here? What if, long before humans, there were other civilizations on our planet, not aliens from another star, but creatures that evolved right here on Earth, millions or even billions of years ago? It sounds wild, but it's not impossible. Earth is old, about 4.5 billion years old. That's a lot of time for things to happen, a lot of time for life to rise, grow, build, and then disappear. What if there were intelligent beings here before us, beings who built cities, made tools, or even flew into space, but left no trace? What if they hit their own Great Filter and vanished? This idea is what we're exploring in this documentary. Could Earth have had other civilizations before humans? And if so, why don't we know about them? Let's start with the Great Filter. The idea comes from a scientist named Robin Hansen, who thought about why we don't see alien civilizations. He suggested that there's a step, or a series of steps, that's really hard for life to get past. Think of it like a video game with a level that's almost impossible to beat. Life might start easily enough. Maybe simple bacteria form in a pool of water. That's level 1. Then maybe those bacteria evolve into more complex creatures like fish or plants. That's level 2. But getting to a civilization, one that builds tools, writes books, or sends signals into space, that's a much harder level. And even if a civilization gets that far, staying alive long enough to spread across the stars might be the hardest level of all. The Great Filter could be anywhere along that path. Maybe it's early, like when life first tries to start. Maybe it's later, when civilizations get smart but mess things up. Or maybe it's something we haven't even thought of yet. The scary part about the Great Filter is that we don't know where it is. Are we past it? Are we still approaching it? If the filter is behind us, that's good news. It means the hardest part is done. and maybe we're one of the few species to make it this far. But if the filter is ahead of us, that's bad news. It means something out there could stop us, just like it might have stopped others. And if it stopped others here on Earth, long before humans, that makes the question even bigger. What happened to them? Earth has been around for a long time. Like I said, 4.5 billion years. That's hard to wrap your head around. A billion years is 1,000 million years. In that time, life has changed a lot. We know from fossils that simple life, like bacteria, showed up maybe 3.5 billion years ago. That's a long way back. Over time, life got more complex. Fish appeared, then amphibians, then reptiles, then mammals. Dinosaurs ruled for millions of years before a big asteroid hit, about 66 million years ago, and wiped most of them out. After that, mammals like us got a chance to evolve. But what if, somewhere in those billions of years, something else got smart? What if there was a species that figured out how to build things, think deeply, or even dream about the stars, just like we do? The idea of a pre-human civilization on Earth isn't just science fiction. It's something scientists have thought about. Even if it sounds strange at first, they call it the Silurian hypothesis, named after a fictional race of intelligent reptiles from the TV show Doctor Who. The idea is simple. If an advanced civilization existed on Earth millions of years ago, would we even know? The answer might surprise you. Most of what we build doesn't last forever. Think about our cities, our roads, our skyscrapers. If humans disappeared tomorrow, how long would it take for nature to erase them? Scientists say it wouldn't take long at all. In a few hundred years, most buildings would start to crumble. In 1,000 years, they'd be mostly gone. In 1,000,000 years, there'd be almost nothing left. Wind, rain, plants, and time would wipe away our cities. Even our biggest monuments, like the pyramids or the Great Wall, would eventually turn to dust. Now imagine a civilization that lived 100 million years ago. That's a long time. Longer than dinosaurs have been gone. Even if they built huge cities or left behind machines, those things would be gone by now, buried under layers of rock, washed away by oceans, or crushed by glaciers. The Earth is always changing. Mountains rise and fall, continents move, rivers carve new paths. All of this would hide the traces of any civilization that came before us. Even fossils, which we rely on to learn about ancient life, don't always survive. Bones turn to stone only under the right conditions, and most things that die just rot away. If a civilization existed and didn't leave behind durable stuff like metal or plastic, there might be no fossils at all. This brings us to another big question. What counts as a civilization? When we think of civilizations, we usually think of humans, people building cities, writing books, or launching rockets. But a civilization doesn't have to look like us. Maybe it was a species of intelligent dinosaurs that figured out how to use tools. Maybe it was a kind of octopus that lived in the oceans and built underwater structures. Maybe it was something we can't even imagine, like creatures made of different chemicals than us. The point is, a civilization is any group of beings that can think, plan, and build things together. They don't need to look like humans or act like humans. They just need to be smart enough to change the world around them in a big way. So why don't we see any signs of these older civilizations? One reason is that Earth is really good at cleaning itself up. Over millions of years, natural processes like erosion, volcanic eruptions, and plate tectonics, the movement of the Earth's crust, destroy evidence. Think about it like a chalkboard that gets erased over and over again. Every million years, the Earth wipes itself clean. Rocks get buried, melted, or turned into new rocks. Oceans cover old land. Glaciers scrape away the surface. If a civilization existed 50 million years ago, its cities could be buried under miles of rock or lost at the bottom of the sea. Even if they left behind something durable, like a piece of metal, it might be so deep underground that we'd never find it. Another reason we might not see evidence is that we're not looking in the right places. Scientists study fossils to learn about the past, but fossils are mostly about bones, shells, or plants. If a civilization used tools made of wood or other soft materials, those wouldn't last. Even if they used metals, those could rust away or get crushed into nothing. And if their civilization was small, maybe just a few cities instead of a whole planet full of them, it'd be even harder to find anything. Imagine trying to find a single needle in a haystack the size of a planet. That's what looking for a lost civilization might be like. But there's another possibility. Maybe we have found evidence, but we don't recognize it. What if some of the strange things we've dug up, like weird rocks or unusual chemical patterns, are actually clues to a forgotten civilization? Scientists have found things in the Earth's crust that don't quite make sense, like odd levels of certain chemicals or tiny structures that look like they could be artificial. Most of the time we assume these things have natural causes, like volcanoes or bacteria. But what if we're wrong? What if some of those mysteries are the last traces of a civilization that came before us? Let's think about what a pre-human civilization might have been like. They wouldn't have to be like us at all. Humans have only been around for about 300,000 years, and we've only had things like cities and writing for about 10,000 years. That's a tiny sliver of Earth's history. A civilization from 100 million years ago could have been completely different. Maybe they didn't build cities like ours. Maybe they lived in harmony with nature, leaving no big marks on the planet. Or maybe they built huge structures, but those structures were made of materials that broke down over time. Maybe they didn't use fire or metal, but instead used something else, like bioluminescent plants or organic tools. The possibilities are endless. One thing to think about is how long a civilization lasts. Humans have only had advanced technology for a couple hundred years. Think steam engines, electricity, computers. If we disappeared tomorrow, how long would our stuff last? Plastic might stick around for a while, maybe a few 100,000 years. But even plastic breaks down eventually. Metal rusts, concrete crumbles. In a million years, there'd be almost nothing left of us. Now imagine a civilization that lasted for 10,000 years, 100 times longer than our modern world. Even that is just a blip in Earth's history. If they existed 50 million years ago, their traces would be long gone. This idea gets even more interesting when you think about what might have caused these civilizations to disappear. That's where the great filter comes back in. Maybe they got too smart and built something dangerous, like a weapon that destroyed them. Maybe they changed the climate of the Earth like we're doing now, and couldn't survive the consequences. Maybe an asteroid hit, or a volcano erupted, or a disease wiped them out. The Earth has seen a lot of disasters over its history, big ones, called mass extinctions, where most life on the planet died out. The dinosaurs went extinct because of an asteroid. Other mass extinctions happened because of climate changes or volcanic eruptions. Any of those could have been a great filter for an earlier civilization. Let's talk about mass extinctions for a moment. Scientists know of at least 5 big ones in Earth's history. The biggest was about 250 million years ago, called the Permian-Triassic extinction. It wiped out about 90% of all species. Imagine a civilization existing back then. Even if they were super smart, could they have survived something that killed almost everything? Probably not. And if they did survive, they might have been so weakened that they couldn't rebuild. Over time, their cities would crumble, their tools would decay, and their story would be lost. This brings us to another point. Time is the enemy of evidence. The farther back you go, the harder it is to find anything. Most of the Earth's surface today wasn't even around 100 million years ago. The continents have moved, the oceans have shifted, and the rocks have been recycled. The Earth's crust is like a big conveyor belt, always moving and changing. Old rocks get pushed down into the Earth, melted, and turned into new rocks. This process, called plate tectonics, is why it's so hard to find really old stuff. The oldest rocks on Earth are about 4 billion years old, but they're rare. Most of the planet's surface is much younger. If a civilization existed 1 billion years ago, their traces might be locked away in those rare old rocks, or gone forever. So, how would we even look for a lost civilization? Scientists have some ideas. One is to look for weird chemicals in the ground. When humans build things, we leave behind stuff like plastics, metals, or radioactive particles from nuclear tests. If an ancient civilization used similar things, we might find traces of them in rocks or sediment. For example, scientists have found strange layers of carbon or other chemicals in rocks from millions of years ago. Most of the time they think these come from natural events, like asteroids or volcanoes. But what if some of those layers are from a civilization burning fuel or building machines? It's a long shot, but it's worth checking. Another way to look is to search for fossils, not just of bones, but of things that might show intelligence. Imagine finding a fossilized tool or a piece of something that looks like it was made, not grown. That would be a huge clue. The problem is, fossils are rare, and most things don't fossilize at all. Soft stuff like wood or skin disappears fast. Even hard stuff like metal can break down over millions of years. But if a civilization used something really durable, like a special kind of rock or crystal, we might find it. Scientists are also looking at tiny fossils, like those of bacteria, to see if they show signs of being messed with by intelligent life. There's another angle to this. What if the civilization wasn't on land? Most of Earth's surface is covered by water. If an intelligent species lived in the oceans, their traces would be even harder to find. Ocean floors get recycled faster than land. The oldest ocean crust is only about 200 million years old, compared to billions of years for some land rocks. An underwater civilization could have built amazing things, coral-like cities, glowing structures, who knows? And we'd never find them because the ocean ate them up. This idea of a lost civilization isn't just about Earth's past, it's about our future too. If other civilizations rose and fell here, what does that say about us? Are we doomed to hit the same great filter? Right now, humans are doing things that could be dangerous. We're changing the climate by burning fossil fuels. We're building powerful technologies, like artificial intelligence, that could get out of control. We're even exploring space, but we're still fragile. One big mistake, a war, a disease, a bad choice, could wipe us out. Thinking about ancient civilizations makes us wonder, did they make the same mistakes? Did they see their end coming? Or were they caught by surprise? The Fermi paradox and the Great Filter aren't just about aliens or lost civilizations. They're about us. They make us ask big questions. Why are we here? How did we get this far? And most importantly, how do we keep going? If Earth has seen other intelligent species rise and fall, it's a warning. It tells us that being smart isn't enough. We have to be careful. We have to think about the long term, not just the next 10 years, but the next 10,000 or even 10 million years. If we want to avoid the Great Filter, we need to learn from the past, even if that past is hidden under layers of rock and time. So where does this leave us? The idea that Earth had civilizations before humans is a big one. It's hard to prove, but it's not impossible. The universe is full of mysteries, and Earth is no exception. Maybe we're the first ones here, or maybe we're just the latest in a long line of experiments. Either way, the Great Filter is out there, waiting. It's up to us to figure out how to get past it. This documentary is about exploring that idea, looking for clues, imagining what might have been, and thinking about what it means for our place in the universe. Let's keep going and see what we can find. The Earth is like a giant history book, but most of its pages are missing, torn out by time, wind, water, the slow grind of moving continents. If there was a civilization on this planet, millions or billions of years before humans, finding proof would be like searching for a single grain of sand on a beach. Yet, there are hints, strange things in the rocks, odd patterns in the ground, and mysteries in the fossil record that make us wonder. Could these be the faint echoes of a lost world? In this chapter, we'll dig into the clues that might point to a pre-human civilization, exploring what scientists have found and what it could mean. Let's start with the rocks. Earth's crust is full of secrets, but it's not easy to read them. Over billions of years, the planet has been reshaped by forces like volcanoes, earthquakes, and glaciers. These forces bury, melt, or crush almost everything on the surface. If a civilization existed 100 million years ago, their cities, tools, or machines would likely be gone, turned to dust, or buried deep underground. But some things might survive. Not big things like buildings, but tiny traces, like unusual chemicals or strange marks in the rock. Take the Permian-Triassic boundary, about 250 million years ago. This was the biggest mass extinction in Earth's history, when about 90% of all species died out. Scientists have found strange chemical signals in rocks from that time. like sudden changes in carbon isotopes, different versions of the carbon atom. These changes are usually blamed on huge volcanic eruptions that pumped gases into the air. But some researchers wonder if something else could have caused them. Could an advanced species have been messing with the environment? Maybe burning resources or experimenting with technology and accidentally triggered a catastrophe? We don't know, but the idea makes you think. Another clue could be in the fossils or the lack of them. Fossils are rare. Most things that die don't turn into fossils, they just rot away. For something to become a fossil, it needs to be buried quickly in the right conditions, like mud or sand that hardens into rock. Bones, shells, and teeth fossilize best. But what about tools or machines? If a civilization used wood, leather, or other soft materials, those would disappear fast. Even metals rust or break down over millions of years. But if they use something really tough, like a special kind of stone or crystal, we might find it. Scientists have found odd things in the fossil record before, like tiny tube-like structures from billions of years ago that look almost too perfect to be natural. Most say these are just bacteria or minerals. But what if there's something else, like the remains of a tool or a piece of technology? One place to look is in the Earth's chemical record. When humans build things, we leave behind evidence. Burning coal and oil creates carbon dioxide and other gases that change the air and get trapped in rocks or ice. Nuclear tests leave radioactive particles that can last for thousands of years. Plastics and metals pile up in the ground. If an ancient civilization did similar things, we might find their fingerprints in the Earth's layers. For example, scientists have found weird spikes of carbon or nitrogen in rocks from millions of years ago. Most of the time, they think these come from natural events like volcanic eruptions or asteroid impacts. But what if some of these spikes were caused by a civilization burning fuel, making chemicals, or even fighting wars? It's a stretch, but it's not impossible. Another place to look is in the Earth's magnetic record. The planet's magnetic field has flipped many times over its history, and these flips leave traces in rocks. If a civilization used electricity or machines, they might have left tiny magnetic signals in the ground. Scientists have found weird magnetic patterns in some ancient rocks, but they usually explain them as natural, caused by lightning or mineral deposits. Still, it's possible that some of these signals could be artificial, left by a civilization that had technology we can't even imagine. Then there's the idea of technosignatures. That's a fancy word for signs of technology. When humans build cities or factories, we change the land in ways that can be seen from space. Roads, dams, or huge fields of crops. If an ancient civilization did something similar, we might spot it in the rock record. For example, mining leaves behind piles of waste or strange patterns in the ground. Large-scale farming can change the soil or leave pollen from crops that don't seem natural. Scientists have found layers of ash or soot in rocks from millions of years ago, usually blamed on wildfires or volcanoes. But what if some of that ash came from a civilization burning fuel or fighting wars? It's a long shot, but it's worth thinking about. There's also the mystery of anomalous artifacts. These are things that don't quite fit with what we know about the past. For example, in the 1800s, miners in Europe found what looked like a metal nail embedded in a 100-million-year-old rock. In another case, a strange bell-shaped object made of metal was dug up in coal that was millions of years old. Scientists usually dismiss these as hoaxes or mistakes, like modern objects that got mixed up with older rocks. But what if some of them are real? What if they're the last scraps of a civilization we don't understand? The problem is, these finds are rare, and most don't hold up under scrutiny. Still, they make you wonder what else might be out there, waiting to be found. One big challenge is that we might not recognize a techno-signature even if we saw it. Our idea of technology is based on what humans do: metal, plastic, concrete, electricity. But what if a civilization used completely different materials? Maybe they built with living things like coral or plants that wouldn't fossilize the same way. Maybe they used crystals or chemicals we don't understand. Or maybe their technology was so advanced that it looked like magic to us, leaving no trace we'd know how to spot. If their civilization was small, maybe just a few cities instead of a whole planet, it'd be even harder to find. Let's think about time for a moment. Earth is 4.5 billion years old. Humans have only been around for about 300,000 years, and our modern civilization, think cars, computers, and cities, is only a couple hundred years old. That's nothing compared to the planet's history. A civilization that lasted 10,000 years, 100 times longer than our modern world, would still be a tiny blip. If they existed 100 million years ago, their traces would be buried, crushed, or washed away by now. The Earth's surface is always changing. Continents slide around, oceans rise and fall, and glaciers scrape everything clean. The oldest ocean floor is only about 200 million years old, so any underwater civilization would be almost impossible to find. Even on land, most rocks are younger than 1 billion years because of plate tectonics, the way the Earth's crust moves and recycles itself. This recycling process is a big reason why finding evidence is so hard. Imagine you write a story on a piece of paper, but every few years, someone tears it up and makes a new sheet. That's what Earth does with its surface. Old rocks get pushed down, melted, and turned into new rocks. Fossils get destroyed. Chemicals get mixed up. If a civilization existed 1 billion years ago, their stuff might be locked away in rare ancient rocks or gone forever. The oldest rocks we've found are about 4 billion years old, but they're tiny and hard to study. Still, those rocks are where we might find clues, like strange chemical patterns or microscopic fossils that don't fit. There's also the possibility of finding megastructures, not huge buildings, but things like mines, quarries, or dams that change the landscape in big ways. Humans leave marks like this. Think of the giant open-pit mines we dig for copper or coal. If an ancient civilization did the same, we might find traces in the rock record, like unusual layers of sediment or strange cuts in the ground. Scientists have found odd geological formations before, like perfectly round holes or symmetrical patterns that don't always make sense. Most get explained as natural, but some could be worth a second look. Another idea is to look for microfossils, tiny traces of life, like bacteria or algae, that might show signs of being manipulated. For example, if a civilization used bacteria to make fuel or clean up waste, those bacteria might leave unusual patterns in the fossil record. Scientists have found microfossils from 3.5 billion years ago that look like simple life, but some are weirdly complex, with shapes that don't quite match natural processes. Could they be the remains of something artificial, like a bioengineered organism? Probably not, but it's worth checking. Scientists are starting to think about how to search for these clues. One idea is to look for isotope anomalies. Isotopes are different versions of elements, like carbon-12 and carbon-13. When life or technology changes the environment, it can leave unusual isotope patterns. For example, burning fossil fuels today creates a specific carbon isotope signature. If an ancient civilization did something similar, we might find that signature in old rocks. Scientists have already found odd isotope patterns from millions of years ago, like during the Cambrian period, about 540 million years ago, when life suddenly got more complex. Most think this was just evolution at work. But what if it was more than that? What if some intelligent species was tinkering with the environment? The ocean is another place to think about. Most of Earth's surface is water, and the oceans are full of mysteries. If a civilization lived underwater, maybe intelligent fish or squid-like creatures, their traces would be even harder to find. Ocean floors get recycled fast, so anything older than 200 million years is probably gone. But we might find clues in coastal rocks, where the land meets the sea. For example, strange deposits of minerals or shells could hint at underwater structures or farming. Scientists have found weird shell piles from millions of years ago, usually blamed on natural currents. But what if they were made by someone piling them up on purpose? This search isn't just about the past. It's about understanding our place in the universe. If we find evidence of a lost civilization, it would change everything. It would mean Earth has seen intelligence before, maybe many times. It would mean the Great Filter has struck here already, wiping out those who came before us. And it would be a warning. Whatever stopped them could stop us too. But it would also be exciting. It would mean we're not alone, even if our predecessors are long gone. It would mean Earth is a place where intelligence can rise, even if it struggles to last. All of these ideas, chemicals, fossils, artifacts, structures, depend on one big assumption, that we'd know what to look for. A civilization from 1 billion years ago might be so different from us that their traces don't look like anything we'd recognize. Maybe they didn't use metals or burn fuel. Maybe they lived in ways that blended with nature, leaving no scars on the land. Or maybe their technology was so advanced that it's invisible to us, like trying to explain a smartphone to someone from 10,000 years ago. If we're going to find them, we need to think outside the box. So, where do we go from here? Scientists are already looking at rocks, fossils, and chemicals in new ways, asking questions they didn't ask before. They're using tools like mass spectrometers to study isotopes, microscopes to look at tiny fossils, and satellites to spot strange patterns in the ground. Every year, we learn more about Earth's history, and every discovery brings us closer to answering the big question: were we the first? In the next chapter, we'll imagine what these ancient civilizations might have been like, from their biology to their technology, and how they might have met their end. Imagining a civilization that existed on Earth millions or even billions of years before humans is like stepping into a science fiction story, but one grounded in the possibilities of our planet's long history. If intelligent beings rose here before us, they could have been wildly different from anything we know. They might not have been mammals, or even carbon-based life forms. Their societies, technologies, and fates could challenge everything we assume about what it means to be a civilization. In this chapter, we'll explore what these pre-human societies might have looked like, how they could have lived, and what might have caused their downfall, tying their stories to the Great Filter, the mysterious barrier that seems to stop civilizations from lasting or spreading. Let's start with the question of who or what these beings could have been. Earth's history is full of strange creatures, from the tiny microbes of 3.5 billion years ago to the towering dinosaurs of the Cretaceous period. Intelligence doesn't require a human-like body. Consider the octopus, a modern creature with a complex brain, capable of solving puzzles and using tools. Now imagine a species like that evolving millions of years ago, perhaps in the oceans of the Devonian period, about 400 million years ago, when life was thriving in the seas. These creatures might have developed intelligence to navigate coral reefs, hunt in groups, or build structures from shells or coral. Their civilization could have been underwater, with glowing bioluminescent cities, or intricate networks of tunnels carved into the ocean floor. They might have communicated with light or sound, leaving no physical traces that would survive the relentless recycling of the ocean crust. Or picture a terrestrial species, perhaps descended from early reptiles or even dinosaurs. Some dinosaurs, like the Troodon, had relatively large brains for their size, hinting at the potential for intelligence. What if a branch of these creatures, living 100 million years ago, evolved to use tools? They could have built shelters from wood or stone, crafted weapons for hunting, or even developed a primitive form of writing, scratching symbols into rock or bone. Their society might have been nomadic, following herds of prey across ancient plains, or they could have settled in fertile valleys, creating structures that blended with the landscape. Unlike human cities, their buildings might have been organic, made from materials like wood or hide that wouldn't fossilize well, making them nearly invisible to us today. Now, let's push the boundaries further. What if a civilization wasn't carbon-based like us? Earth's early history, billions of years ago, was a time of extreme conditions, hot, volcanic, with oceans rich in minerals. Some scientists think silicon-based life could have existed in such environments. Silicon, like carbon, can form complex molecules, though it's less flexible. Imagine a civilization of silicon-based creatures thriving in the scorching heat near volcanic vents. Their technology might have been crystalline, using minerals to channel energy or store information. Their cities could have looked like glittering fields of quartz or obsidian, structures that, over time, would blend back into the Earth's crust, mistaken for natural rock formations by modern geologists. What would these societies have done? A civilization doesn't need skyscrapers or spaceships to be advanced. They might have been farmers, cultivating strange plants or algae in ancient oceans. They could have been builders, creating dams to control rivers or canals to irrigate crops. Or they might have been thinkers, developing philosophies or mathematics without ever writing them down in a way we'd recognize. Their technology could have been biological, breeding creatures to do work, like we breed horses or dogs, or engineering bacteria to produce energy. They might have used fire, or they might have harnessed electricity from natural sources, like lightning or geothermal heat. If they were advanced enough, they could have left Earth entirely, launching primitive spacecraft or sending signals into space, only to vanish before we arrived. The key to their existence, though, is how they interacted with their world. A civilization leaves marks, even if they're subtle. Human activity today changes the planet. Deforestation, mining, pollution. An ancient civilization might have done the same. Imagine a species that burned vast forests for fuel, releasing carbon into the air and leaving layers of ash in the rock record. Or one that mined minerals, creating unnatural piles of debris that puzzled future geologists. They might have altered rivers, built artificial lakes, or even changed the climate, triggering disasters that became their great filter. These changes could leave clues, odd chemical spikes, unusual sediment layers, or patterns in the ground that don't quite fit natural processes. Now, let's think about their culture. Did they have art? Did they tell stories? A civilization doesn't just build things, it creates meaning. They might have carved symbols into cliffs, painted caves with pigments we've mistaken for natural stains, or sung songs that echoed across ancient landscapes but left no trace. Their beliefs could have been tied to the stars, the sea, or the earth itself. Maybe they worshipped volcanoes or feared comets, seeing them as omens of their end. Their social structures could have been as varied as ours, tribes, kingdoms, or something entirely different, like hive-like communities where individuals worked as one. The most intriguing question is what brought them down. The Great Filter could take many forms, and Earth's history offers plenty of possibilities. Let's imagine a few scenarios. First, consider a civilization from 250 million years ago, during the Permian period. They might have been thriving, building cities along ancient coasts, when massive volcanic eruptions in what's now Siberia released huge amounts of gas, warming the planet and poisoning the air. This was the Permian Triassic extinction, which killed 90% of all species. Even a smart species might not have survived such a catastrophe. Their cities would have been buried under ash, their tools swept away by floods, their legacy erased as the Earth recovered. Or picture a civilization 66 million years ago, just before the asteroid that killed the dinosaurs. Perhaps they were a species of intelligent reptiles, mastering fire and building stone structures. When the asteroid hit, it caused wildfires, tsunamis, and a global winter that blocked out the sun. No matter how clever they were, they couldn't outrun the collapse of their ecosystem. Their ruins would have been pulverized by the impact, scattered by erosion, and buried under layers of sediment, leaving nothing for us to find. The Great Filter doesn't always need to be a natural disaster. It could be self-inflicted. Imagine a civilization that developed technology like ours, maybe even more advanced. They could have built machines that polluted the air, poisoned the water, or changed the climate. Sound familiar? Humans today are grappling with climate change caused by burning fossil fuels. An ancient civilization might have done the same, pushing their environment past a tipping point. Rising temperatures, dying crops, or collapsing ecosystems could have ended them, leaving only faint chemical traces in the rocks. Another possibility is war. If they were anything like us, they might have fought over resources, land, or power. Advanced weapons, whether spears, explosives, or something we can't imagine, could have destroyed their society. Picture a global conflict that left their world in ruins, with survivors struggling to rebuild until the next disaster finished them off. The evidence of such a war might be subtle: a layer of ash, a spike in radioactive elements, or a sudden shift in the fossil record where their species disappears. Then there's the chance they created something they couldn't control. Today, humans worry about artificial intelligence or bioengineered diseases getting out of hand. An ancient civilization might have faced a similar problem. Maybe they built machines that turned against them, or they engineered a virus that wiped them out. Their great filter could have been their own ingenuity, a lesson that intelligence can be as dangerous as it is powerful. What if they didn't fail completely? Maybe a few survived, retreating to hidden corners of the earth, deep caves, remote islands, or the ocean's depths. Over millions of years, their descendants could have evolved into something else, losing their intelligence or technology. Or perhaps they left Earth, escaping to space before their filter hit. Their spacecraft might still be out there, drifting in the void, or they could have settled on another planet, only to face a new filter there. These ideas are speculative, but they remind us how fragile a civilization can be, even one that seems unstoppable. Let's consider one specific scenario: a civilization of aquatic creatures in the Cambrian period, about 540 million years ago. This was a time when life exploded in diversity, with strange creatures filling the oceans. Imagine a species of intelligent trilobites, hard-shelled creatures with complex eyes. They could have developed a society based on cooperation, using their claws to build structures from sediment or coral. Their technology might have been organic, like using bioluminescent algae to light their underwater cities. But then, a shift in ocean chemistry, maybe caused by their own actions, like farming or waste, made the water toxic. Their civilization collapsed, and their remains were buried in the sediment, mistaken by us for natural fossils. Another scenario: a dinosaur-like civilization 100 million years ago during the Cretaceous. They might have been small, agile predators using tools to hunt and build. Their society could have been spread across a supercontinent, with trade routes and early forms of communication, but their reliance on a stable climate made them vulnerable. A series of volcanic eruptions or their own environmental damage caused global cooling, starving their crops or prey. When the asteroid hit, it was the final blow. Their stone tools and structures were ground to dust, leaving only a few odd fossils that we've overlooked. These stories are guesses, but they're built on what we know about Earth's history. The planet has seen countless changes: ice ages, warm periods, mass extinctions. Any civilization would have faced these challenges just as we do today. The Great Filter could have been one big event, or a slow grind of mistakes and bad luck. Whatever it was, it erased them so completely that we're only now starting to wonder if they existed at all. Thinking about these lost societies does more than spark our imagination. It makes us question our own path. If intelligent beings rose and fell on Earth before, what stopped them? Were their filters the same as the ones we face? Climate change, war, technology run amok? Or were they something else, something we haven't even considered? By imagining their lives and their ends, we get a glimpse of what might be waiting for us. The clues we explored in Chapter 2, chemical anomalies, strange fossils, or geological oddities, are the starting point. Now we've given those clues a story, a shape. In the next chapter, we'll look at how these possibilities warn us about our own future, and what we can do to avoid becoming just another layer in the Earth's forgotten history. The idea that Earth might have hosted intelligent civilizations before humans is more than a curious thought. It's a warning. If other societies rose and fell on this planet, erased by time or catastrophe, they point to a chilling possibility: the Great Filter. That invisible barrier that stops civilizations from enduring could be waiting for us too. In the last chapter, we imagined what those ancient societies might have been like, from ocean-dwelling thinkers to tool-using dinosaurs, and how they might have met their end. Now we turn the lens on ourselves. The Great Filter's shadow looms over humanity and the challenges we face today. Climate change, technological risks, societal conflicts might be echoes of the same forces that ended those who came before us. This chapter explores how the possibility of past civilizations informs our own risks, what science tells us about potential filters, and how we might avoid them to secure our future. Humanity is at a crossroads. We've achieved wonders in a short time. In just a few hundred years, we've gone from horse-drawn carts to landing on the moon, from handwritten letters to instant global communication. Our cities glow at night, visible from space, and our machines can think, learn, and create. But with every step forward, we create new dangers. Climate change is warming the planet, melting ice caps and fueling storms. Nuclear arsenals could destroy entire nations in minutes. Artificial intelligence, while promising, could outpace our ability to control it. These are not just problems. They could be our great filter, the wall that stops us from becoming a lasting star-faring civilization. If Earth has seen other intelligent species fall to similar threats, their stories urge us to act with caution and foresight. Let's start with climate change, a threat that feels all too familiar when we think about ancient civilizations. Imagine a pre-human society, perhaps 200 million years ago, that burned vast stores of organic material for energy, much like we burn fossil fuels today. Their actions might have warmed their world, disrupted ecosystems, or poisoned their air, leading to collapse. Today we're doing something similar. Since the Industrial Revolution, humans have released massive amounts of carbon dioxide by burning coal, oil, and gas. Global temperatures are rising. 2024 was one of the hottest years on record, with average temperatures 1.5 degrees above pre-industrial levels. Sea levels are creeping up, threatening coastal cities. Extreme weather, hurricanes, droughts, wildfires, is becoming more common. Scientists warn that if we pass critical tipping points, like the collapse of the Amazon rainforest or the thawing of Arctic permafrost, the consequences could be unstoppable. The fossil record offers clues that past climate shifts were devastating. During the Permian-Triassic extinction 250 million years ago, volcanic eruptions released greenhouse gases, warming the planet by up to 10 cars. Oceans turned acidic, and most life died out. If an intelligent species existed then, even their ingenuity might not have saved them from such a rapid global catastrophe. Our situation isn't that extreme yet, but we're on a risky path. The Intergovernmental Panel on Climate Change, IPCC, projects that without drastic cuts to emissions, we could see 3-4 degrees warming by 2100, disrupting food supplies, flooding cities, and displacing millions. If a past civilization fell to environmental collapse, it's a stark reminder we must act now, shifting to renewable energy, protecting ecosystems, and rethinking how we live to avoid our own climate-driven filter. Another potential filter is technological hubris, creating tools we can't control. Consider an ancient civilization that developed advanced biology, perhaps engineering microbes to produce food or fuel. If those microbes escaped, they could have spread like a plague, wiping out their creators. Today, we face similar risks with artificial intelligence, AI. AI systems are growing smarter, capable of designing drugs, writing code, or even making decisions in war. By 2025, AI models like those developed by xAI are advancing rapidly, with some predicting they could rival human intelligence within decades. But what happens if AI becomes too autonomous? A misprogrammed system could disrupt economies, infrastructure, or worse, trigger conflicts. In 2023, AI researchers warned about existential risks from unchecked systems, urging global cooperation to set safety standards. The parallels to a lost civilization are eerie. If an ancient species built machines, mechanical or biological, that turned against them, their downfall could mirror our fears about AI. Science fiction often paints scenarios of rogue AI, but real-world risks are subtler: biased algorithms, automated weapons, or economic upheaval from mass automation. To avoid this filter, scientists and policymakers are working on AI governance rules to ensure systems remain transparent and controllable. Organizations like the AI Safety Institute are studying ways to align AI with human values, but progress is slow and global agreement is hard. If a past civilization fell to their own creations, it's a lesson. We must prioritize safety over speed in our technological race. War and conflict are another filter that might have ended ancient societies. Picture a civilization 100 million years ago, divided into factions fighting over resources. Their weapons, whether primitive or advanced, could have escalated to mutual destruction, leaving only ash in the geological record. Today, humanity faces similar dangers. Nuclear stockpiles hold over 12,000 warheads, enough to end civilization many times over. Tensions between nations over land, water, or ideology persist, with conflicts in 2025 showing no sign of slowing. Emerging technologies like hypersonic missiles or cyber weapons make wars faster and deadlier. If an ancient civilization destroyed itself through conflict, their scattered remains warn us to seek peace, cooperation, and disarmament. To avoid the same fate, disease, too, could be a filter. The Black Death killed up to 50% of Europe's population in the 14th century, and modern pandemics like COVID-19 showed how fragile our systems can be. An ancient civilization might have faced a similar fate, perhaps unleashing a pathogen through bioengineering or environmental disruption. Today, advances in synthetic biology let us edit DNA, creating new crops or cures, but also new risks. A lab leak or deliberate misuse could unleash a disease we can't stop. Scientists are working to prevent this, with global health organizations like the WHO monitoring biothreats and developing rapid response systems. But vigilance is key. A single mistake could echo the fall of a forgotten species. Resource depletion is another threat. If a pre-human civilization overused their forests, water, or minerals, their collapse could mirror our own challenges. Today we're consuming resources faster than Earth can replenish them. By 2025, overfishing has depleted 90% of global fish stocks, and freshwater shortages affect 2 billion people. Deforestation in the Amazon is nearing a tipping point, threatening global oxygen and carbon cycles. Ancient societies might have faced similar limits, perhaps strip mining their land or exhausting their food sources, leading to starvation or migration failures. To avoid this filter, we're exploring sustainable practices, circular economies, reforestation, and lab-grown food. But scaling these solutions is urgent. These threats, climate, technology, war, disease, resources, aren't just abstract. They're interconnected, amplifying each other. A climate crisis could spark resource wars, which could trigger technological missteps or pandemics. If past civilizations fell to such cascades, their absence in the fossil record is a red flag. Science offers tools to fight back. Satellites track climate changes, AI models predict risks, and global networks share knowledge. But tools alone aren't enough. We need collective will, governments, communities, and individuals working together. Initiatives like the Paris Agreement aim to cut emissions, while peace talks and tech ethics summits seek to reduce conflict and AI risks. These efforts are steps toward bypassing the filter. The possibility of pre-human civilizations adds urgency to these challenges. If they existed and failed, their stories are buried in Earth's layers, a cautionary tale written in stone. Did they ignore warnings like we sometimes do? Did they think they were invincible, as we often assume? Their extinction suggests the great filter is real, and we might be closer to it than we think. Yet humanity has an edge. We can learn from the past, even if it's speculative. By studying Earth's history, its extinctions, climate shifts, and mysteries, we can spot patterns and avoid repeating them. We're the first species to understand the filter's threat, giving us a chance to outsmart it. Avoiding the filter means thinking long-term. Ancient civilizations might have lived for thousands or millions of years, yet still vanished. Our civilization, barely 10,000 years old, is young by comparison. We must plan not just for decades, but for centuries or millennia. This means protecting our planet, controlling our technologies, and resolving conflicts peacefully. Scientists are already helping geologists study past climates, engineers design sustainable systems, and ethicists guide AI development. But it's not just up to experts. Every choice we make, how we vote, what we consume, how we treat each other, shapes our path. If we want to avoid the fate of those who came before, we must act with purpose and unity. The Great Filter's shadow is long, but it's not inevitable. If past civilizations fell, they left no manuals, no warnings carved in stone. Yet their absence speaks volumes. Survival is not guaranteed. Humanity's strength lies in our ability to reflect, adapt, and imagine a better future. By learning from the ghosts of Earth's past, we can chart a course through the dangers ahead. In the next chapter, we'll look beyond Earth, exploring what the possibility of lost civilizations means for life in the cosmos, and how we might become a species that not only survives, but thrives among the stars. If Earth hosted intelligent civilizations before humans, their rise and fall reshape how we view our place in the universe. The Great Filter, the barrier that might have erased these ancient societies, isn't just an earthly problem. It could explain the silence we hear when we search for life among the stars. The Fermi paradox, that nagging question of where is everybody, looms larger if our planet has seen multiple failed civilizations. In this final chapter, we explore what the possibility of pre-human societies means for the search for extraterrestrial intelligence, the challenges of becoming an interstellar species, and the hopeful paths humanity can take to bypass the filter and thrive in the cosmos. The lessons from Earth's past push us to think bigger, not just about our survival, but about our potential to connect with the universe. The idea that Earth could have been home to intelligent beings millions or billions of years ago changes how we approach the Fermi paradox. If civilizations rose and fell here, leaving no trace, it suggests the universe might be full of similar stories. Worlds where life bloomed, grew smart, and then vanished. The Milky Way has about 100 billion stars, many with planets in the habitable zone where liquid water could exist. Estimates from the 2024 Kepler mission data suggest there could be 10 billion Earth-like planets in our galaxy alone. Yet, despite decades of listening with radio telescopes like those at SETI, we've heard nothing definitive. No signals, no signs of alien megastructures, no cosmic greetings. If Earth's history includes lost civilizations, it might mean the Great Filter is common, snuffing out intelligent life before it can shout loud enough to be heard. What does this mean for the search for extraterrestrial intelligence? If the filter struck here multiple times, it could be a universal hurdle. Maybe life starts easily, bacteria-like organisms forming in primordial soups across countless worlds. Fossils from 3.5 billion years ago show Earth had simple life early on, and experiments like the 1953 Miller-Urey study proved that life's building blocks can form under common cosmic conditions. But getting from microbes to minds might be rare, and surviving as a civilization rarer still. If ancient Earth societies hit their filter, whether through climate collapse, war, or technological missteps, other planets might face the same fate. This would explain the silence. The universe could be littered with the graves of civilizations that never made it past their own filters. This grim possibility doesn't mean we should give up searching. Instead, it sharpens our focus. If the filter is real, we need to look for different signs of life. Instead of expecting loud radio signals or Dyson spheres, massive structures around stars to capture energy, maybe we should search for subtler clues. Ancient Earth civilizations might have left faint chemical traces, like carbon spikes or isotopic anomalies, as we explored in Chapter 2. Alien worlds could hold similar hints. In 2025, telescopes like the James Webb Space Telescope are scanning exoplanet atmospheres for biosignatures like oxygen or methane that suggest life. If we extend this to technosignatures, say unusual chemical pollutants or artificial heat patterns, we might find evidence of failed alien civilizations, just as we hunt for signs of Earth's lost ones. The filter's implications also shape how we think about our own cosmic ambitions. If pre-human civilizations tried to reach space and failed, their story warns us of the challenges ahead. Space is unforgiving. Radiation, microgravity, and vast distances make colonization a daunting task. A 2024 study on Mars habitability found that sustaining a colony would require decades of Earth support, with crops struggling in Martian soil and cosmic rays posing health risks. An ancient Earth species, perhaps launching probes 300 million years ago, might have faced similar hurdles, their spacecraft lost to time, or their colonies collapsing on distant moons. Humanity's efforts, SpaceX's Starship missions, NASA's Artemis program aim to overcome these barriers, but we must plan for the long haul, building resilient systems to survive off-world. The filter might not just be one event, but a series of tests. If Earth's past civilizations fell to cascading crises, climate shift sparking wars, or technology triggering environmental collapse, the same could happen on other worlds. This suggests the universe might not be empty, but filled with planets where life tried and failed to endure. In 2025, astrobiologists are studying exoplanet habitability models, predicting which worlds might support life. If we find planets with strange atmospheric signatures, say high levels of industrial pollutants, it could mean a civilization rose and fell, leaving a chemical ghost. This idea pushes us to refine our search, using AI to analyze vast datasets from telescopes and probes to spot these fleeting traces. But the filter's shadow isn't the whole story. If Earth has seen multiple civilizations, it means intelligence can arise, even if it struggles to last. This is hopeful. It suggests the universe isn't barren, but fertile with potential. Humanity's unique advantage is our awareness of the filter. Unlike a dinosaur-like society 100 million years ago, unaware of an incoming asteroid, we can predict and prepare. We're tracking near-Earth asteroids with missions like DART, proving we can deflect them. We're modeling climate scenarios to avoid tipping points. We're debating AI ethics to prevent runaway systems. If past Earth civilizations lack this foresight, their loss is our gain. We can learn from their absence, using science and cooperation to outsmart the filter. Becoming an interstellar species is one way to beat the filter. If a pre-human civilization stayed earthbound, a single disaster like the Permian-Triassic extinction could wipe them out. Spreading to other planets or stars makes us harder to erase. In 2025, plans for lunar bases and Mars missions are accelerating, with private companies and governments aiming for permanent off-world settlements by 2050. But this requires more than rockets. We need sustainable ecosystems. Think closed-loop habitats with recycled water and food grown in space. An ancient civilization might have tried this, only to fail from resource shortages or technical errors. Our success depends on learning from those hypothetical mistakes, investing in robust technologies and global collaboration. The cosmos also challenges us to think about communication. If ancient Earth societies sent signals into space, they might have been too weak or short-lived to reach us. Today, we're broadcasting radio waves and planning laser-based messages, but these fade over vast distances. A 2024 study estimated that our signals are detectable only within a few light years without advanced alien receivers. If we want to connect with others, we need to think bigger, perhaps building massive beacons or sending physical probes like Voyager that carry our story. If past civilizations tried and failed to be heard, their silence urges us to shout louder and smarter, ensuring our voice carries across the galaxy. The possibility of lost Earth civilizations also reframes our philosophy. If intelligence arose here multiple times, only to vanish, it suggests life is precious but fragile. This echoes in the cosmos. Every planet with life might be a fleeting spark, winking out unless it overcomes its filter. Yet this fragility inspires action. Humanity can choose to be different. We can build a culture of resilience, valuing knowledge, sustainability, and unity. Movements in 2025, global climate strikes, open source science, cross-nation space projects show we're trying. If a Cambrian aquatic civilization or a Cretaceous reptilian society fell to division or greed, their loss teaches us to prioritize the collective good over short-term gains. Hope lies in our ability to dream beyond Earth. If pre-human civilizations never left the planet, their story ended here, but we can write a different ending. Imagine humanity 1,000 years from now, with colonies on Mars, moons, or distant stars. We'd need to solve the filter's challenges: climate, technology, conflict, but doing so would make us a cosmic species, no longer bound to one fragile world. Scientists are laying the groundwork. Fusion energy research promises clean power. Genetic engineering could adapt humans to alien environments, and quantum computing might unlock new ways to navigate the stars. These are the tools to bypass the filter, but they require wisdom to wield. The universe might be silent because the filter is ruthless, but it doesn't have to stay that way. If Earth's past holds ghosts of lost civilizations, their legacy is a call to action. We can be the species that breaks the cycle, that survives where others fell, by learning from Earth's history its extinctions, its mysteries, its potential lost worlds, we can forge a path to the stars. The Fermi paradox asks why we're alone, but the answer might be that we're not meant to stay that way. Humanity's future lies in reaching out, building bridges across the cosmos, and proving that intelligence can endure. As we close this documentary, we look to the stars, not with fear, but with determination to write a story that echoes through the ages. What makes the idea of a great filter so unsettling is its uncertainty. We don't know if it's behind us or ahead, a single event or a series of hurdles. If ancient Earth civilizations existed, their disappearance suggests the filter is closer than we'd like. Consider the Ordovician-Silurian extinction 440 million years ago, when sudden climate shifts wiped out 85% of species. An intelligent aquatic species might have thrived then, only to be erased by cooling seas. Today we face similar uncertainties, unpredictable climate feedbacks or technological tipping points. Scientists are developing models to predict these risks, using data from ice cores, tree rings, and ancient sediments to understand past collapses. By mapping these patterns, we can better prepare, but only if we act on the warnings, unlike those who might have ignored them millions of years ago. Social division could also be our filter, just as it might have been for others. Imagine a pre-human society split by ideology or resources, unable to unite against a looming threat like a changing climate. Today, political polarization and misinformation hinder global cooperation. In 2025, disputes over climate policies or tech regulations often stall progress, even when the stakes are clear. If an ancient civilization fractured under similar pressures, their failure to work together could have sealed their fate. We're trying to bridge these gaps through international summits, open science, and grassroots movements, but unity remains elusive. Learning from a lost society's collapse could push us to prioritize collaboration over conflict. Space itself might hold a filter. If a pre-human civilization reached for the stars, they could have faced insurmountable challenges: radiation, resource scarcity, or navigation failures. Today we're taking our first steps into space, with missions to Mars and plans for lunar bases. But space is hostile. A 2024 study estimated that a Mars colony would need decades of support from Earth to survive. If an ancient species tried and failed to colonize another world, their abandoned outposts might be dust by now. Our space efforts, backed by companies like SpaceX and agencies like NASA, aim to overcome these hurdles, but we must plan carefully. A failed leap to the stars could drain our resources, leaving us vulnerable back home. Economic inequality is another potential filter, one that could mirror ancient failures. A civilization 100 million years ago might have collapsed if a few hoarded resources while others starved, sparking unrest or weakening their resilience. In 2025, the top 1% own over 50% of global wealth, while billions live in poverty. This gap fuels instability, from protests to migration crises. If a past society fell to such imbalances, it's a warning to address inequality now. Efforts like universal basic income experiments or fair trade policies aim to close this gap, but they face resistance. A balanced society, where resources and opportunities are shared, might be key to surviving the filter. Then there's the risk of cosmic events, which no civilization past or present can fully control. Asteroids, solar flares, or supernovae could have ended ancient societies just as they threaten us. The dinosaur-killing asteroid 66 million years ago shows how sudden these events can be. Today, we're tracking near-Earth objects with telescopes and developing deflection technologies like NASA's DART mission, which successfully altered an asteroid's path in 2022. But we're not fully prepared for larger threats, like a massive solar flare disrupting power grids. If a pre-human civilization fell to a cosmic disaster, it reminds us to invest in planetary defense, ensuring we're ready for the unexpected. Finally, the psychological weight of the filter could itself be a hurdle. If an ancient civilization realized their world was at risk, despair or denial might have paralyzed them. Today, doom scrolling and climate anxiety affect millions, sapping the will to act. Yet, we also see hope, youth movements, scientific breakthroughs, and global solidarity in crises. If past civilizations succumb to fear or apathy, their lesson is clear. We must stay resilient, fostering optimism and action. By confronting the filter head-on, through innovation, cooperation, and determination, we can rewrite our story, proving we're not just another lost chapter in Earth's long history.